Guys, if anyone need polarization, any clarification, ask them to come here. Guys, if anyone need polarization, any clarification, ask them to come here.
Some doubts are there. Any questions come? Okay.
Actually, as we have, especially in your section, we have not discussed wave optics part. We have discussed about interference, diffraction till now, and now we are dealing with polarization. Interference, and diffraction, diffraction will be understood with the help of wave nature of light. Same way, polarization also, this process of polarization also will be understood with the help of wave nature of light only. So, all this interference, diffraction, and polarization, these three phenomena, experimentally observed phenomena, will be understood with the help of wave nature of light. Wave nature of light. But when you say polarization, specifically, especially the properties, actually, they will be understood with the help of transverse nature of waves only. Or you can say that the properties like polarization can be exhibited only by transverse nature of waves, transverse waves. So that's why light is considered as electromagnetic wave, as light is an electromagnetic wave. In electromagnetic wave, electric field and magnetic field will be vibrating perpendicular to the direction of light propagation. In this, specifically in light, okay, the electric vector only will be mainly will be responsible for optical effects. In electromagnetic wave, in electromagnetic wave, you can say only electric field E vector, only E vector will be responsible for, mainly responsible for, will be mainly responsible for optical effects. Optical effects. So hereafter you have to keep in mind that the amplitude of light, electric field vector, and intensity is corresponding intensity you have to deal with. So here what you have to say is the electric vector, electric field vector, or electric vector. The electric, the electric vector or electric field vector of the wave will be identified as light vector. Will be identified light vector. Light vector means if you consider light wave having some amplitude, that amplitude of light wave vector nothing but amplitude of electric field vector, like that you have to consider, and the intensity of light should be related to intensity of electric field vector, like that you have to deal with. So when you say when you are dealing with a polarization by making use of the what you call transverse nature. What did you say? Actually, the transverse polarization will be exhibited by only transverse waves. Transverse waves. So you can say as transverse nature of light. Transverse waves exhibit polarization. Polarization. So with this we can say simply what is first of all polarization. Polarization is nothing but to understand this first you need to have an idea about what is unpolarized light and polarized light. Then you can have an idea about polarization. So to understand this you should know what is unpolarized light. Unpolarized light. So unpolarized light will be considered as the light having vibrations in all possible directions is called unpolarized light. So light having vibrations of electric field vector or electric vector. So in horizontal direction, vertical direction, like in all possible directions, the light having. But it will ask perpendicular also. That's right. Actually, in all possible directions, it can have perpendicular to the direction of propagation in one direction. It is a three-dimensional wave, right? Wave is a three-dimensional. So it can have the possibility to have the vibrations in all these directions. Possibility. So in these possibilities, you can have this is the one which is having possibility of having the what do you call vibrations in all possible directions can be treated as what, unpolarized light. Light simply say unpolarized. Whereas if you remove all the other possibilities of having the vibration planes, if you confine all the vibrations to a particular plane, like like this vertical plane, hmm, then this kind of light having a particular plane, confined plane of vibration will be called as polarized light. Polarized light. Okay, it may be confined to vertical plane or horizontal plane, like a to and fro, into the plane and out of the plane, into the plane of the paper and out of the plane of the paper, like this here, like this, up and down here, into out. This also will be considered as polarized light. This polarized light is also called as plane polarized or linearly polarized. Linearly polarized. Linearly polarized. Okay. So this just here, in addition to this, you need to have an idea that if it is completely only having one plane of vibration, then we call it plane polarized. But number of possibilities you can have, it is unpolarized. But maybe more than one, if they're having but less than many, something like that, only two, for example, it is having the horizontal plane vibration and a vertical plane, horizontal and vertical plane, like this kind of possibility is there. Or here it is having both and here one, like this kind of possibilities are there. This kind of waves are called as partially polarized. Partially polarized lights. In two directions. Yes. In two planes. Yes. Okay. Partially polarized light, you can call it as. So now, when we are dealing with this polarization, so unpolarized light, you have understood what is unpolarized light. Then polarized or plain polarized or linear polarized means making one-sidedness. Making one-sidedness is called polarization. So this process is called polarization. So we can define polarization as the process or phenomena of confining vibrations of electric vector to a particular direction is called as polarization. So we can define it as polarization. We can define this as the process of confining what confine vibrations of electric vector. Yes, vibrations of electric vector or electric field vector, either way you can call it as electric vector or electric field vector to a particular plane or direction, anyway you can call it as to a particular to a particular to a particular direction, a particular plane will be called as polarized. Specifically, that particular direction will be specifically perpendicular to the direction of propagation. So the process of confining vibrations of electric vector to a particular direction perpendicular to the propagation direction. Perpendicular to the propagation direction is called as polarization. Okay, so to produce this polarization, we will use different methods. So briefly, just I'll give you that the methods of producing polarized light. Methods of of methods of producing polarized light. Methods of producing polarized polarized light. Briefly, you can say there are many methods are there, out of which we can say one of the method is by using Polaroid, and we can produce a polarized light by using a reflection process, right? And also you can produce this by using a refraction process, and also you can produce this by using a double refraction method, and also you can produce this by using some thin filters. But all these things will not consider here. Okay, so only these two. Let us try to look into little briefly. Here, this is one of the very important one is this. So let us see how can you produce what you call polarization by using Polaroids. So first, to understand this, you need to have an idea about first what is Polaroid. Polaroid. Polaroid is nothing but a device which is used to produce polarized light. It's called Polaroid. What is then again here? how can you represent that device is that usually it is nothing but a sheet, circular shaped sheet or rectangular shaped or square shaped sheet is called polaroid, which produces polarization. Polarization means if you passes unpolarized light through it, having a number of possible what you call vibrations, it will confine possible what you call the vibrations to one particular direction, either a horizontal plane or a vertical plane. Okay, so you can say polaroid is nothing but a device. We can call it as so a device which produces you can say what you call polarized light. Device which produces polarized polarized light. Produces polarized light. Of course, it works based on a particular property, special property called selective absorption property. That means it will absorb all other vibrations except one particular vibration. So we call it, that also we have to just I have to mention when you are dealing with when you are describing about the polarized. So it is a device which produces polarized light by using selective absorption property. By using selective absorption property. Absorption property. Yes. Here, this Polaroid, which is producing a polarized light, will be called as a polarizer. Okay, we usually will call it as polarizer. So, if you are using a polarizer as a polaroid as a polarizer to produce what do you call polarized light, how it behaves and how to understand this phenomena, or you can say that the effect of polarizer on what do you call it, the light incident on it, unpolarized light. So to understand this, let us see. You can say that especially effect of polarizer on the light means the intensity, how the intensity will be, variation of intensity uh, due to polarizer. I have to say, okay, variation of intensity, variation of intensity, intensity due to polarizer, due to polarizer, or you can also say effect of polarizer on unpolarized light. So if, for example, if you are allowing an unpolarized light through a polarizer can be considered as a circular sheet. If you are passing the unpolarized light means it will be having the vibrations in all possible directions is unpolarized light. So if it is having its what do you call this axis of the polarizer, we call it as a transmission axis or pass axis. Pass axis, that means the axis which passes a particular vibration is called pass axis. Pass axis or transmission axis. Transmission transmission axis. So what is this? The axis which allows a particular vibration parallel to this axis is called pass axis. Particular vibration which is parallel to this axis is called pass axis. If this axis is parallel to this one, this will be allowed. It acts like a slit, actually speaking. It acts like a slit. So if say for example, if there is a wall and one door kind of opening is there, if 10 members are like traveling here, 10 members, the person who is without deviating their path, if they're coming, the one which is facing exactly the opening, if he will cross into the door, the others will just simply collide with the wall and they will stop. Like this you can understand this. So what happens here is just further to understand this, just what you have to consider is, if an unpolarized light is having some amplitude a naught, and uh, so let me consider this the other way. Say if it is coming all this only the one which is parallel to this, that means the one like in this way, having the vibrations in this way, will come out with some intensity. If it is having some intensity I naught here, the intensity will changes. How it will changes, to understand this, let me give you one small mathematical representation. As a generalized case, I will consider if you are having this is a vibration, electric field vector vibration, and this is what you call pass axis. If this is a vibration, electric field vector vibration is having amplitude a naught and it is making an angle theta. So if it is parallel to this, directly the a naught will come out, but because of this we have to resolve this into two components. So a component of this will be a naught cos theta, will be along this pass axis, and another one perpendicular to this will be a naught sin theta, a naught sin theta will be perpendicular to this. So the component which is parallel to this what you call axis will come out. So here the resultant amplitude will be the amplitude of the light which is coming out is not A naught. Okay, the coming out intensity will be amplitude will be A equal to A naught cos theta, A naught cos theta, which is parallel to the path axis. This is path axis parallel to the path axis. So the corresponding intensity can be expressed as intensity is proportional to A square. You can say here I is proportional to A is A naught cos theta. So A naught cos theta whole square. So we can write this as I is equal to some constant K into A naught square into cos square theta. This gives you the I naught. But actually, there is a possibility for this angle to change from 0 to what you call 360 degrees. So unpolarized light, unpolarized light, all values of theta starting from 0 to 2 pi are possible for the rotation purpose. So you can say that you have to take all the possible values of theta from 0 to 2 pi, and if you take the average of this, if you take the average of this average, then we'll get I is equal to, we have to just from actually that means we have to take the integration. You have to take this average, means average you can take it as by making use of integration. We are not getting into the details of those. So k a naught square into integral of if you take this cos square theta d theta from with limits 0 to 2 pi radians, the average value of this will give you you can take it as this is something like if you take k a naught square is intensity, corresponding intensity. If you take it as I naught, k a square itself, k a square. If you take k a square a naught square as I naught, then you can write it as I naught. Okay, so here if you are taking this average value of this can be taken as a integral of your cos square theta d theta by 2 pi you have to take when we are taking this average. So otherwise just you can take it as integral of this will be equal to, this is I naught into 1 by 2 will get the entire value. Why? Because of this is a average means over a given period, or over the entire what do you call circular total cycle. So we have to take it as in terms of 2 pi. Over a given period means you have to take with respect to period means t you have to take with respect to theta means you have to take the total angular what is it angular position 2 pi. So on simplifying this we'll get 1 by 2, so we'll get I naught by 2. So this will be the intensity of light coming out in terms of I. So whereas amplitude will be A naught cos theta, intensity will be I equal to I naught by 2. So in terms of amplitude, if you want to express this one as I is A square, I naught is A naught square. Okay, then you can write it as A naught by root 2. So you can also write it as the corresponding amplitude as A equal to A naught by root 2 we can take. Okay, so with the help of this, you can also say that. So what we are dealing here is when unpolarized light comes through a polarized light. What do you call it? Plane polarized light comes out, whose intensity is given by I naught by 2. Intensity of the light coming out of a single polarizer is this. But if you want to know whether it is polarized or not, we have to use another polaroid. You can call it as analyzer. But here you have to use another polaroid. You can call it as analyzer. So we now need to understand this. Let us try to take the heading like effect of analyzer on plane polarized light. Effect of analyzer. This is a very important point. Effect of analyzer on plane polarized light. So when you consider this, you have to say that if there is an unpolarized light having the vibrations in all possible directions, if you make this to pass through first a polarizer, if you make this to pass through first a polarizer, polaroid P1 will be polarizer, and if its path axis is this, these vibrations will come out with intensity. You can say after first polarizer, whatever the intensity coming, if you take it as I1, I1 can be taken as I naught by 2. If the incident intensity of unpolarized light is I naught, then it will be I naught by 2. This is again allows to pass through another polaroid P2 if you call it as analyzer. Analyzer. This can be called as polarizer. Polarizer. This analyzer, if depending on the orientation of this intensity here, we can call it as I2 or I. It depends on the intensity which is passing through this. Intensity which is passing through here is I0 by 2. If you take it as some I1, then it is observed experimentally that intensity coming out of polarizer here, you can take it as directly proportional to cosine square of the angle between the pass axis of polarizer and analyzer. This observation is called as Malus law. We call this as Malus law. Malus law. So Malus law says that intensity coming out of an analyzer, you can write like a statement. What it states that is intensity of polarized light. Intensity of polarized light transmitted through analyzer or coming out of analyzer. Transmitted through analyzer or coming out of analyzer. Okay, you can simplify. Transmitted through analyzer. Through analyzer is proportional to this is our I is which is proportional to cosine square of theta. What is the theta? Theta is angle between the transmission axis of analyzer and polarizer. Proportional to the cosine square of the angle between plane of polarization and plane of analyzer. Plane of transmission of, or you can say simply proportional to cosine square of angle between pass axis or transmission axis. Can you call it as pass axis or between angle between transmission axis plural. Yes, XE means plural, XA means singular. Between transmission axis of analyzer and polarizer. Analyzer and polarizer. Okay, so how can you understand this is if you have unpolarized light and this is polarizer, first polaroid is polarizer, another polaroid if you are using as analyzer, but if this is the transmission axis, the transmission axis of this is like this, for example. So with respect to this, if it is a vertical, it is making an angle theta. Then if the intensity something is here, but here the intensity which is passing through analyzer, this is polarizer, is if it is I0, then here the intensity coming out is proportional to cos square of this theta. We can write it as I is equal to this proportionality constant can be taken as this incident intensity I0 into cos square theta. This expression will be called as Malus law. This expression can be called as Malus law. If you have only two polarizers, if intensity here is I0, otherwise if this is I0, this will be I0 by 2. This is I0, this will be I0 by 2. That way you have to take it. This is general relation, but specifical example one we can take. If unpolarized light of intensity I0 is taken, and if you take this as a polarizer, the intensity coming after the first polaroid, we call it as polarizer, can be taken as I1, which is equal to I0 by 2. And if this is passing through another polaroid P2, we can call it as analyzer. Then here the light coming intensity of light coming out of this, if you take it as a second polaroid is I2, which is equal to I1 into cos square theta. I1 into cos square theta. Here I1 is I0 by 2. So if you have two polarities, okay, two polarities, so you can also write it as what this is. I2 is equal to I0 by 2 into cos square theta. If this is a parallel, theta can be 0, then this also will be I0 by 2 only. If it is oriented at some angle 30 degrees, 6 degrees, or like that, accordingly you have to take this theta. Whereas here another example I will give. Here if you have, instead of if this is unpolarized light with intensity I naught is passing through first polaroid, then second polaroid, then third polaroid, then fourth polaroid. Four polarides are there. So here, if this is I naught, the one coming out of the first one, if you take it as I1 can be will be first polaroid will be always called as polarizer, but other polarides will be called as analyzers. This is analyzer, I can take it as A1, analyzer 1, this is analyzer 2, this is analyzer 3, but this is polarizer. First one will be polarizer, which is producing polarized light from unpolarized light. So once after getting polarized light, all these are still what you call filtering that intensity. So they're analyzing intensity in different ways. So because of their orientations. So now, if you arrange like little briefly, if they're arranging, if you're arranging this at some different angles with respect to this, if it is arranged at some angle, this is at some angle theta 1, and if this is with respect to this angle, if it is at some different angle, so uh, with respect to this it is at angle theta 2, and with respect to this if it is again here something like this. Here we have to take with respect to this and with respect to the previous one, with respect to the previous one, not with respect to the first one is no, it is not correct. With respect to previous one only you have to consider. Okay, then you can say that I1 should be equal to I1 can be equated as here for first polarizer always it should be I naught by 2. That's it. Next, when dealing with analyzers, I2 will be equal to this I1 into cos square. That angle here is theta 1. Got it? It may be 30, 60, whatever it is. Okay? Then, if this is I2, if this is I3, then I3 will be equal to, so I1 is I naught by 2, so you can write it as I naught by 2 into cos square theta 1, theta 1. Next, I3 will be, for I3, this will be the incident intensity, I2. So I2 into cos square theta 2 we have to take, but I2 is this, I2 is I1 cos square theta 1. So it is equal to I1 cos square theta 1 into cos square theta 2, right? But I1 is I1 cos square theta 1, right? But this I1 is I naught by 2. This is, so you can write this as I naught by 2 into cos square theta 1 into cos square theta 2. Likewise, if you are observing this one, here you can, if you take it as I4, I4 I3 will be incident 1. So accordingly you have to take for number of polarizers. Okay, based on this, we have got some numericals also. Okay, this is what we call as Malus law. Malus law. Whereas the another method of producing polarized light is by reflection. By reflection. Here, based on this, you can see some questions here. Let's see some questions. Yeah. Here, the 16th one, I think we have worked out this, right? There, yeah. Let's see some example. Question number 16. It is page number 234. It is given that the question is unpolarized light passes through a polarizer and analyzer which are at an angle of 45 degrees with respect to each other. The intensity of polarized light coming from analyzer, that is output analyzer, is 5 watt per meter square. Intensity of unpolarized light incident on polarizer is. So there are one polarizer and one analyzer. First will be always called as polarizer. Polarizer. Second one will be called as analyzer. So here, if you consider, this is P1, this is P2. Polarized. This is also polarized only. But here, if you are using unpolarized light, this is unpolarized light with intensity some I naught. So here, the angle between the pass axis is 45. It means so analyzer you have to properly, carefully you have to arrange. So this axis should be 45 degree, making an angle of 45. This will be theta, where theta is equal to 45 degree, and so that the intensity of polarized light coming from analyzer this is analyzer. Here light coming is, if it is, this is I naught, this is output of first one is I1, output of second one is I2. This is given as 5 watt per meter square. Then what is then the intensity of unpolarized light incident on polarizer? What is I naught is the question. So if I2 is equal to 5 watt per meter square, what is I naught is the question in this diagram.
Sir, when this light passes from this to this will be a half of I naught. The intensity will be reduced in half when it passes.
Here, that you have to remember always. Once unpolarized light passes through first polarizer, here it is having all directions. When confined to particular direction, immediately the intensity becomes half of this. That means I naught by 2. That means I1 is equal to I naught by 2.
Instead of polarizer, if it passes to analyzer, it will be reduced in half or it will be the same intensity.
First unpolarized light, when it passes through polarizer, then it becomes half, first point. Then it passes through analyzer, then what it becomes, it depends on the angle of this axis. So this will be input for this. Then for analyzer you have to use Malus law. From Malus law, I2 will be equal to, the input intensity for this is I1 into cos square theta. Here I1 is I naught by 2 into cos square, here theta is 45. So this based on this angle it will be. So we can express this as it is equal to I naught by 2 into cos 45 is 1 by root 2, whole square is 1 by 2. But the intensity of light coming out of the analyzer is given I2 is 5. So this is 5. Then what is I naught is the question. Now if you simplify this, I naught equal to 5 into 4. So I naught is equal to 20 watt per meter square. This is how you have to deal with this. So whereas if you observe the next question, that is 17th one, is an interesting one. A beam of ordinary light means unpolarized light. You have to remember that ordinary light means unpolarized. Ordinary light means unpolarized light. Okay, when a beam of unpolarized light incident on a system of 4 polarides, see 4 polarides which are arranged in succession such that each polaroid is turned through 30 degrees with respect to the preceding one. The percentage of the incident intensity that emerges out from the entire system is approximately. So that just how to consider is, we have to consider an axis horizontal line, that is the direction of propagation. Here we have unpolarized light. It is the first it is passing through polarizer. This is the first polaroid is called polarizer. First polaroid will always be called as polarizer. So here in which direction the axis is there, in that direction it will come out, the light will come out. If it is like this, the light comes out parallel to this path axis. Okay, so the intensity of light come after first polarizer will be I1. This is first. How many polarizers are polaroids? There are 4 polaroids. This is first one, second, third, fourth. With respect to first one, second one axis will be at an angle of 30 degrees. So second one will be, if this is vertical, second one will be inclined at an angle of 30 degrees. So this is theta 1. So this is second polaroid. First analyzer whose angle is theta 1. The next one is with respect to this second one is here, right, at 30. From this another one axis is passing here. So that means this is a third polaroid. This is a third polaroid. This is 30 means from here to here is 30 plus 30 60. So this is 30. This also will be 30. Next fourth polaroid, it is again oriented by 30. 30, 30, 60. Next 30 means it will be 90, right? So it will be like this. Like this. From vertical it will be at 90. Got it? But from, if you consider first one, the second one, from here it may be 30, this will be 30, this will be 30. But with respect to vertical it should be 90. So this is a fourth polaroid. Now what you have to understand from the question is the percentage of the incident intensity that emerges out from the system is. So let us consider if this is I0, then I1 will be always from polarizer, it will be I0 by 2. You have to fix in mind, I1 always will be I0 by 2. Next, Next, if you see, the one which is coming out of the first analyzer is I2. This is second Polaroid. Second Polaroid is I2. Third Polaroid is I3. Fourth Polaroid is I4. But second Polaroid is first analyzer. So from Malus law, I2 is equal to I1 into cos square theta 1 is equal to I1 is I0 by 2 into cos square theta 1 is how much? 30 degrees. So cos 30 is root 3 by 2. So we can write it as root 3 by 2. Cos 30. Cos 30 root 3 by 2. 45 is 1 by root 2. Yes, cos. Okay, sin 30 is 1 by 2. Cos 6, cos 30 is root 3 by 2. So whole square is 3 by 4. I naught by 2 into 3 by 4 is equal to 3 I naught by 8. This is I2. Similarly, if you want I3, for I3 is equal to I2 into cos square theta 2. But I2 is, this is I2. So I2 is 3 I naught by 8 into cos square 30. Again 3 I naught by with respect to the previous one only. With respect to previous one only, not with respect to the initial. With respect to only previous. Only previous. So it will be the angle. So if it is 30, again cos 30 is root 3 by 2 whole square will be 3 by 4. So we can write it as 9 I naught by 8 fours. 32, 32. That is I3. Then I4, last one is I4, right? I4 is equal to I3 in 1, which is nearly 20, is the third option. So you can take it as 21%. So X will be equal to 21%. Okay. So similarly, you can observe here this percentage of intensity is given. But for that, what should be the corresponding angle you are asked to find? Yes, that means it is, if you see, two Polaroid sheets are placed, only two Polaroid sheets are placed one over the other with their axes inclined to each other at an angle of theta. If only 12.5% of the intensity of the light incident on the first sheet emerges out from the second sheet, then the value of theta is, you can say, one over the other or side by side also. So something like this. Like this, this is first sheet. This is second sheet, which is inclined at an angle theta. So this is a pass axis, means the pass axis of the second should be at an angle theta. So if incident is unpolarized light, if it is I naught, this is first Polaroid called polarizer. Second Polaroid will be called as analyzer. This is polarizer and analyzer. Let us say this is I1, this is I2. I1 always will be equal to I naught by 2. I1 always will be equal to I naught by 2. Then I2 will be equal to I1 cos square theta. This I1 is nothing but I naught by 2 into cos square theta. So what is given here is, if only 12.5% of intensity of light incident on the first sheet emerges out. So that is I2. So that is here I2 is 12.5% of I0. I2 is equal to 12.5% of means of incident 1 I naught. 12.5% means you can say 12.5% by 100. Percent means 100 into I naught, right? Yes. So here this is I2 1. This is also I2. If you equate these two, you can write this as I naught by 2 into cos square theta is equal to 12.5 by 100 into I naught. This gets cancelled. For this much percentage of light is coming out of the second, means at what orientation it is there, what is the angle. So to find this, I have to simplify this. What is this? 2 50s. 12.5, how many times it goes? 2 times. 50. 12.5, 2 times is 50. 4 times, huh? Yeah, 4 times. 2 into 12. It is 25, 4 times. So it is equal to 1 by 4. Cos square theta is 1 by 4. Cos square theta is 1 by 4, and hence we can write this implies cos theta is equal to 1 by root 4 is 1 by 2. So the corresponding angle theta will be equal to 60. Hmm? Yes. Similarly, you can just practice the other ones. So all based on this, all are like kind of similar kind of answer. You can just try the other ones. Hmm?
Some same also.
So an unpolarized light is incident on a plate of refractive index root 3 and the reflected light is found to be completely plane polarized. The angles of incidence and refraction are yes. So here we till now we have discussed about the Malus law by polarization by the polarized. Here to have an idea about this you need to have an idea about polarization by reflection. Polarization by
Brewster law.
reflection, we call it as Brewster's law or Brewster's law. What is Brewster's law says is when light incident on a surface interface of two media, this is rarer medium, this is denser medium. If light incident here, then if it is a normal, a part of it will be reflected, a part of it will be refracted. So if this is angle of incidence, this will be angle of reflection. From loss of reflection, angle of reflection will be equal to angle of incidence, and this will be angle of refraction. You can take it as. But it normally, if this is unpolarized, having vibrations in all directions, both reflected and refracted will be partially polarized. Normally, means both are partially polarized. Here, both reflected and refracted refracted rays will be or beams will be partially polarized when when the angle of incidence I is less than a particular angle called polarizing angle. But if it is incident angle is equal to specific angle called polarizing angle, then the reflected light will be completely polarized. If it is less than this, both will be partially polarized. Whereas if an angle of incidence is exactly equal to a special angle called polarizing angle, it will be fixed for fixed interfaces. If it is air glass, it will be approximately for glass. You have to take this as like a note. For air glass interface, polarizing angle will be approximately 57 degrees. For air water interface, polarizing angle will be approximately equal to 53 degrees. Approximately. This will be given as in the data only. So for an idea I'm giving you. So if the angle of incidence is less than this, both reflected and refracted will be partially polarized. Less than this. If it is exactly equal to that for that particular pair, then reflected light will be completely polarized, provided the vibrations in this reflected will be perpendicular to the plane of the paper or plane of the whatever it is, board or whatever it is. Perpendicular to means in out, not parallel to means you can represent with lines. So but this will be partially polarized. It will have perpendicular ones and parallel ones, perpendicular one and parallel one, parallel to this plane also. So it is partially polarized, but this is completely polarized, reflected one. So from this we can say that different points just you can get another observation based it is drawn by this guy Brewster is that at this particular angle called polarizing angle, it is also experimentally observed that reflected light and refracted light are observed to be perpendicular to one another. That is, angle between them should be 90. It is reflected as completely polarized, and the angle between them is observed to be 90. Right? And from these observations, it is given that if this is some normal. If we take this as some n dash is a normal, if this is point is O, then for this from the figure you can say that some of the angles here will be taken as 180. So one is I, this is 90 plus R will be equal to 180. So you can say from figure I plus 90 plus R is equal to 180. From this you can say R is equal to 90 minus I. This I is nothing but polarizing angle. Polarizing angle. If R is 90 minus polarizing angle, then if you apply what you call Snell's law at O, Snell's law at O gives that Sine I of polarizing by sine of R. R will be sine of R. You can take this can be expressed as sine of R will be 90 minus polarizing angle. It will be equal to mu 2 by mu 1. If mu 2 is the denser medium refractive index, mu 1 is rarer medium refractive index. You can take it as this is mu 1 equal to 1, mu 2 is equal to mu. Then you can take this as mu 2 by mu 1. It is equal to mu by 1. So from this, as sin 90 minus theta is cos IP, you can directly take this as tan IP is equal to mu. So now question number 19, if you see, it is given that an unpolarized light is incident on a plate of refractive index mu is equal to root 3 and reflected light is found to be completely plane polarized. The moment you observe this, that means incident angle is polarizing angle. So if it is completely polarized, reflected light is completely polarized, it means angle of incidence will be a polarizing angle, right? The angles of incidence and refraction are respectively. Angle of incidence is polarizing angle. So, and angle of refraction, we are asked to find what is this and what is R. Under this situation, can be expressed as 90 minus IP. So, what is this? Both of this we are asked to find. So, we under this condition, we can say what is that? Tan of I polarizing angle is equal to mu, or IP is equal to tan inverse of mu. So here I mu what is this 1 point root 3, right? So if you take it as, you can take it as root 3 60. So simply you can take it as for what angle tan will be root 3 means you have to say directly. So it is equal to tan inverse of root 3 means it is equal to 60 degrees. So IP will be equal to 60 degree. So if once you know IP, R can be expressed as R is equal to 90 minus IP. So 90 minus 60 is 30. 90 minus 60 is equal to 30 degrees. Right? So similarly, just if you see the level 1, so here this kind of questions are given. What is the intensity in terms of watt per meter square? They have given numerical based ones and percentage based ones. Yes. Actually, this we have not thin films in double slit only. Just we have missed this. I thought to give one small some 10 minutes class actually. Missed fringes. Hmm? Missed wavelengths. Thin films is not there. Only wide double slit experiment only. Okay, but but here we have to this one. This one is you need to go through once. What is it called as missing wavelengths in YDSE missing wavelengths concept you need to have an idea about. What is the time? 9:30 already. Let me take the class. All are there in the class. Let me come and take the class there.